we're going to talk about today, since we talked about drawing conclusions already. So given a certain p-value, here's the conclusion we draw. We reject the null or we fail to reject the null. Now we're basing all of these on sample values and then kind of an arbitrary choice of an alpha level. So that means when we choose to reject or when we choose to fail to reject, we might make mistakes. We might reject when we shouldn't, and we might not reject when we should. And when we do that, we create two different types of errors, which is what we're going to talk about today. So when you're running these hypothesis tests, we can make mistakes in two different ways. First, we can make what's called a type 1 error. A type 1 error is when the null hypothesis is actually true, but we reject it. So the original assumption was correct, but based on our sample value, we chose to reject it. So we probably grabbed a rare sample. That rare sample said, it's not possible. We don't believe that the original is still true, so we reject it, when in fact it was, and you just happened to grab a really rare sample. Okay? So type 1, the null is true, but we reject it anyway. We say it's false when we shouldn't have. Type 2 is essentially the exact opposite. With a type 2 error, the null is incorrect. So the null is wrong, but we don't find enough evidence to reject it. So the null was wrong, but we failed to reject it. So when we found our p-value, it wasn't low enough for us to draw the conclusion to reject when we should have. Okay. Now, a different way of kind of visualizing this or thinking about what we're doing here. In a hypothesis test, we have two conclusions we can draw. We can either reject the null or we can fail to reject the null. When we do that, we're either going to be right or wrong. So, if we think of it in this format, if we kind of put it in a table format. So here's the truth along the top. So the truth is, the null is true or the null is false. We're going to make a decision based on our sample values and the conclusion of our test. So my choices are to reject the null or fail to reject the null. So in the chart there, if the null is true, but we chose to reject the null, so that top square, then we've committed a type 1 error. It was right, we got rid of it. Okay, so that is wrong, that was a mistake, type 1 error. If the null is false, and we choose to reject it, then we're fine. We did exactly what we were supposed to do. On the flip side, though, if the null is true, and we fail to reject it, we've made the correct decision. So it was true, we didn't reject it, so we're okay. If the null was false, though, and we fail to reject it, then we've committed a type 2 error. Okay, so the main thing to kind of keep these straight, because most times people get these mixed up, a type 1 error can only happen. The only way you can commit a type 1 is if the null is true. So one of the things they're going to do is they're going to give you scenarios, and they're going to say what type of error was committed. So if you look at what their conclusion was, you have to think about, if the null was actually true, then they could have only committed a type 1 error. If the null is false, we can only commit a type 2 error, because our other conclusion would be correct. Okay? So those are the two that we need to kind of keep straight. Now, when we make our conclusions, we always run the risk of making one of these two types of errors. Which one would be worse? So if I have a type 1 error, it means the null was true, but we got rid of it. A type 2 was that it was false, and we failed to get rid of it. So if we're thinking about that, which one's going to be worse?
1, 2. 1.
You're all right. It's all dependent on the situation. There are times where type 1 will be very bad, and we want to avoid it. There are other times where type 2 is very bad, and we want to avoid it. Now, in either case, it's bad to make the mistake. We don't want to make a type 1 or a type 2 error. But in most cases, one error is much worse than the other. Okay? And that would be the one that we kind of want to try to avoid if at all possible. So, for an example, in medical disease testing, the null hypothesis is usually that a person is healthy. The alternative is that they have the disease being tested for. So the null is that you're healthy. That's what they're going to keep assuming unless they can find evidence that you are in fact sick. Okay? So, if we think about this as far as errors go, if an infected person is diagnosed as disease-free, what type of error has been made? So if we think about this, if we think about our null and alternative hypothesis, so it might help to kind of visualize. The null is that the person is healthy. The alternative is that they're sick. Okay? So, if we read the situation here, an infected person is diagnosed as disease-free. So what type of error has been made? So, in this situation, is the null true or is it false? It's false. We know the person's sick. Okay? So the person is sick, but we diagnosed them as disease-free. So we failed to reject the healthy hypothesis. So what type of error have we committed? Type 2. Okay? So they were sick. The null was false, but we failed to reject the null. We claimed that they were healthy, even though they weren't in fact healthy. Okay? So that would be a type 2 error. Well, in this same situation, if a healthy person is diagnosed as having the disease, then which type have we committed? So this time, was our null true or false? It was true. They are in fact healthy, but we found evidence to reject that null and conclude that they're sick. So what did we commit? Type 1. Okay? So, those would be the two types of errors we can make in this particular setting. Now, between the two of those, which would probably be the worst to commit? Probably type 2 because the person's actually sick and they're not going to get treatment for it. That might be 2. So, that's the other thing you got to look at here. Normally, if you contract some type of disease, if they say you're healthy but you have the disease, you're going to be in trouble because you're not getting the correct treatment, right? So that would probably be the worst of the two errors. But, like Grace just said, if the disease in question was cancer, in most cases, if you have cancer, what's the treatment? Chemo. Now, if someone comes in and they actually don't have cancer, but you start them going through chemo, now you're irradiating their body when they didn't need to be in the first place. So the treatment itself, if it's a dangerous treatment, type 1 might actually be worse. We do not want to start giving someone this treatment if they don't need it in the first place. Okay? So when you look at these types of problems, and you're trying to figure out, based on the scenario, which type is worse to make, you got to think about the context. Okay? Whichever type is the worst to make, you want to try to minimize at all costs. So you want to try to minimize those as much as possible. Okay? And we'll talk about then how we do that based on how we run our test here. So, if we wanted to talk about type 1 errors, so if type 1 errors were something that we wanted to reduce. So think about how a type 1 error occurs. What's the situation in which we create a type 1 error? So how do we commit a type 1 error? Yeah, we reject a true null. Now, what do we use as the basis for the conclusion to reject or fail to reject? The alpha level. So we compare the p-value to the alpha level, right? If our p-value, if we're going to reject a null, what has to be true about our p-value in relation to alpha? It has to be smaller than alpha, right? So, if we think about a type 1 error, we can only make a type 1 error if our p-value is less than alpha. So, the probability that we make a type 1 error should be well, exactly, like how would it calculate? What would the probability of making a type 1 error be then? If I'm only going to reject if p is less than alpha, then what's the probability that I create a type 1 error? If alpha is 0.05, for instance, anything less than 5% gets rejected, right? Well, what's the probability that we get a p-value less than 5%? 5%. If I have an alpha level of 0.1, anything less than 10% would get rejected. So what would be the probability of getting a value less than 10%? 10%. So what's the probability of committing a type 1 error? The alpha level. Okay? So when you run a hypothesis test, the alpha level you choose dictates the probability of committing a type 1 error. So if you pick an alpha level of 0.05, then you're saying that you're going to give yourself a 5% chance of committing a type 1 error. So the significance level, that alpha level that you select, will be the probability of committing a type 1 error, because we will reject the null anytime our p-value comes back as less than that alpha. So, if you're looking at a situation where you're going to gather some information and run a hypothesis test, you've analyzed the situation and you've determined that a type 1 error is one you want to avoid. So you do not want to commit a type 1 error. What would you do for your alpha level? Make it very small. You want a very small alpha level because you don't want to make that type 1 error. Right? Now, if it was one where you didn't necessarily want a type 2 error, so you think type 2 is a much worse consequence, so think about how type 1 and type 2 would be related. If I choose a lower alpha, that means I'm going to reject far less, right? Because my p-value has to be that much smaller in order to reject. Well, if I'm failing to reject more, what type of error will I start making more of? Type 2. So if I'm going to make less type 1s, I'm going to make more type 2s, right? So I can lower my alpha level, and that lowers the probability of type 1. But at the same time, then, that's going to increase my probability of a type 2. So if I look at my situation, and I determine what does a type 1 error look like, what does a type 2 error look like? If I determine that the type 2 error is the much worse of the two, and I want to avoid that, what would I want to do with my alpha level? I'd want to increase it. If I increase it, that means I'm going to reject more. So yes, I'm probably going to make more type 1 errors, but I'm going to make less type 2 in the process, and type 2 was the one I wanted to make sure I avoided. Everyone okay with that idea? So that type 1, type 2, if one goes up, the other has to go down. Now, the only way you can lower both, so the only way you could actually lower both at the same time, what do you think? Bigger sample size. If you take a bigger sample size, you can keep the same alpha or whatever alpha you want, and you can decrease the probability of both types of errors at the same time. So the only way you can decrease both is by taking a larger sample. Otherwise, if you change one, you're going to change the other. Okay? That's it. So, for tomorrow, I want you to finish up the 2 through 20 even, so make sure those get done. Try out these problems here.